I sail toward distant shores, indefinite in time. I shall not be afraid to shout the anthem's cry. I shall not be afraid to shout the anthem's cry, declaring to the schools at large the truth and trust inside. Sing a song for science, hail mathematical tools. You students sail the waters, bearing humanity's jewels. Well, hi everybody on this beautiful morning. He's back. It's me, the friendly astronomer, Larry Burrs, with our follow-through lesson, lesson 3 on the solar system scale model. And it gives me a great deal of pleasure to be today outside in the elements, to be able to discover what it truly means to find your place in space. Where are we? That's the real focus of what we're trying to do. And the key through all of this is to better apprehend where we are than to know where we are. And apprehension involves an experience, and we're here today to have that very experience. Are you ready? Kids, grown-ups, everybody who's listening, we're going on a solar system tour scale size. We need to do that because space is big, and we need outdoor zones to be able to truly experience and encounter the happening of a solar system model. Now, the original idea behind this scale model comes from a wonderful astronomy educator named Guy Otwell, who I wish were with us today, but his inspiration is with me. As his model, I'm going to try to engage and execute right now for you. Are you ready? Well, let's do it. The first thing we need to do, and I hope you will want to try this in time too, is to stay safe and secure wherever you make your model. We have our school located in Limestone right now for that purpose, but you may have an immensely beautiful backyard, or you may be near a play or athletic field, a football field, a soccer field, or you may have a park or just some large zone that gives you an opportunity to walk. Because when we do the solar system model as we're going to do it today, believe it or not, take a deep breath because I will, we're going to need approximately 2/3 of a mile, over 1,000 yards, to be able to walk the full solar system model. Of course, you don't have to do the whole thing when you do it, but I really hope you think about what's going on here as you get a better sense of your place in space. Ready? Set? Here we go. Let's take a walk over to the table of contents. Please follow me. I placed here on a table, and you may want to set up something similar when you do your own model at home or on the road, the materials that we're going to be needing to set up a solar system scale model. Some of these things might already be familiar with you. For example, a meter stick or a yardstick. This is important in scaling. The whole concept of scientific scaling is invaluable in astronomy because things are so big, so far away, so hot, so cold that you have to scale the size of whatever object or phenomena you want to see in astronomy to something that you can get a grip on. It's not like some of the other sciences where you can get the samples right there. So in our case, we're going to take, what is it? Yep, you're right. It's a meter stick in this case, not 36 inches, but 39. That's going to be the standard for our spacecraft. This is going to represent, in our particular case, here's a big number for you, 3,600,000 miles. I say it again, 3,600,000 miles represented, scaled down to 36 inches. If you use a calculator, you can discover that 1 inch is equal to 100,000 miles. If 1 inch is 100,000, 8 inches is 800,000. I bet you already knew that. You're a smart group, I can tell. Maybe you recognize from our inside work in the first 2 lessons with the friendly astronomer our sunball. Well, it's a bowling ball, but the important part is it's 8 inches across, or in diameter, 8 inches. This represents to scale 800,000 miles, the true size of the sun. A number that, well, it's the whole idea between reading and viewing. We we can read lots of numbers, but when we can view it visually, it means something different. What am I going to do with this? We want to have our sun scale model in a position where we can view it from the other planets to scale. Are you ready to walk the walk with me? Well, here I go. What a coincidence. There happens to be an appropriate ladder here. And following all the important regulations and rules set and standardized for ladder climbing, I'm going to keep a good grip on the ladder, and I'm climbing forward, not too high. Now, you may not want to use a ladder at your home, and if you're one of the kids that really like this idea, you certainly want supervision and perhaps someone to scout and spot the ladder as you're going up. I'm going to take the ball and place it in the hollow on top of the ladder so I know it's secure. Obviously, you probably want to work with a smaller ball. If it's a windy day, though, it might blow away. So this is a consideration. And you want to make sure, of course, around the ladder people are far away, and safety first and security for everyone. You want to have fun, you want to learn, but you want to be safe at all times. I'm coming back down. How am I doing, everybody? Pretty good. Wonderful. So we've placed our sun ball to scale in a high position that's convenient to see so we can continue our lesson right now. Back to the materials. I'm going to walk over here, and you're probably going to be familiar with some of the things that I show you. And let's do that again. We need our planets. And very tenderly, I'm going to hold them here to scale. Mercury, Venus, Earth, and Mars, hooray. Everyone say hurrah. I can't hear you. That's better. Mercury, Venus, Earth, and Mars, hooray. Very good, hurrah. Mercury, Venus, Earth, and Mars go whirling and twirling amongst the stars, or the sun, and they all go spinning, around and around they go. It's one thing to see the planets to scale, and we've placed our sun ball in the appropriate ladder position. I have another semi-sun ball that gives you an idea of the scale between planets and our star. And this is a 4 to 5 inch ball, not 8 inches. So the planets to scale would be even smaller than what you see here, but I just want to give you an idea that the sun looms huge. We can read about the size of the sun, but it's one thing to view it and have a model. That's why models in science become so important. You can do this for your particular planet. Models to scale. You want pinheads. I've just gone to one of the local stores, and you can do this too if you don't mind waiting in line these days, and you can pick up a bag of pins, colored pins, and you can see I chose black for Mercury. What color? Black. What color is Venus? Yellow, mellow yellow. You got that too. How about Earth? Blue. And Mars? Red, the red planet. There they all are. And they're in sequential order. That means they're lined up the way they should be from the sun. And they're also the current and scaled size too. So what I'm going to do here, I have my terrestrial planets for you more advanced astronomy kids and students out there. Terrestrial planets. I've got a yogurt container here. It's Greek yogurt. And since the word planet comes from the Greek planetes, wasn't that a good choice by your friendly astronomer? I'm going to open this up, and this is going to be a little travel bag for all my planets and objects. And I'm going to curl them around. Bye-bye, planets. And I'm going to put them inside so they're safe. As I learned on this sort of windy day here in Limestone, a gust of wind can spoil your party really quickly. Thankfully, I recovered the planets. I hope you recover them too. I have other planets too. What about those outer planets? Remember them? Jupiter and Saturn are next in line, hooray, hurrah. Jupiter and Saturn are next in line, hooray, hurrah. Jupiter and Saturn are next in line at Uranus and Neptune. 8, that's great. They all go spinning, around and around they go. Well, it's a happy day. I have some nuts here, whether it's a walnut or a chestnut or a beech nut, that are going to stand for our scaled models of Jupiter, giant Jupiter, and Super Saturn, the Lord of the Rings. I even brought for you specialists a ring for Saturn. Nice, huh? Nothing to it. Into the planet tub they go. I'll even put the ring in there. Hope it doesn't leave one on the bathtub. What's next? Uranus and Neptune. Peanut time! Peanut time! Peanut! Hey, peanut! I've got him here. I'll take 2 peanuts. I say I'll take 2 peanuts. Uranus and Neptune. Now, don't be upset with me. I know one's not turquoise and the other one's not aquamarine, but you can paint them if you want to. That's totally up to you. But the whole idea is that you can get everyday objects to reflect and symbolize your planets. Get in there. Dwarf planets, asteroids, well, time will tell. We need to get on the road, don't we? We're going to be going on our tour right now. I hope you're ready to do this scale size. I'm happy to be with you. I'm ready to begin. Now, I'm going to bring along, and you don't have to do this with your model, but gee, you can have someone hold the planet pin. You can have someone stand where the planet should be, and I don't recommend your little brother or little sister, or even big brother or big sister. They may just walk away, and we don't want that to happen. Well, winter's over, at least in our county, I think. So I brought these old winter stakes, driveway stakes with me that I can put in the ground. You can find maybe a pennant or some kind of other spike to drive in. Maybe put your planet pinhead on a postcard and stick that in the ground. But mind you, if it's windy, things become more difficult. If I had a hammer, I'd hammer in the daytime. So I'm going to hammer away. I'm also going to take the materials here in my planet kit. Bet you don't know what I'm holding here. Maybe you do. It's a piece of welder's glass, strength 14, not 13, not 15, 14. I bought it locally at one of the welder shops, and you can too, or online if you care to go that way. You can hold this in front of your eyes and look safely at the sun. Now mind you, only welder's glass will do this. And I don't want to hear about anybody using any other material that might hurt your eyes. I want to keep everyone safe. Remember, safety first. I'm going to bring it along for a purpose you'll see in just a minute. Are we ready to begin? I can't hear you. Boy, you must be far away. I just can't hear you. Well, we're going to start. Now watch what I'm going to do. I'm going to go over here. It's time to walk the walk. I'm at the origin with the sun still hanging up there. It's a beautiful day here. My, thank you, sun. I'm going to take a deep breath. It's going to be quite a long walk. You better take a deep breath too. Ready? Here we go. Don't you feel better? What's the first planet from the sun that we know of, at least? It looks like that's the one. Yes, yes, I can hear you. Mercury. Mercury. So, what do I know about Mercury? Well, you can find this out too from a book, online. It's 36 million miles away. And we also know from the stick of conscience, our yard meter stick in this case, that's 3,600,000 miles. 36 million. That would be 10 strides, because 10 times 3,000, 3,600,000 is 36 million, I think. I'm right. Here we go. I'm going to Mercury. Ready? Deep breath. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Quite a ride on our pacecraft. Mercury. Now I'm looking back here and facing the sun. It's interesting, it looks pretty big. Now the great benefit of a scale model is that what you see here is equivalent to what's really going on in outer space. Because the angles that we see subtend, which is a fancy word saying it's the same angle even though the distance is different of the target, in this particular case, the sun. Watch what I'm going to do. I have my planet cup. I open the cup. Mercury, where are you? There you are. Now you may do this. You may have your mom, your dad, a grandfather, a grandmother, aunt, uncle, brother, sister to help you. Be careful. Don't drop it. Mercury and the sun. Now this is a very awesome moment. I hope you feel a little awe. Because here's Mercury. Now probably most of you probably your tender ages, rarely if never see the planet Mercury in the sky. Why? Because it's the closest planet to the sun, and it really doesn't travel too far away from the sun in the sky. There are only special times in the year when it becomes visible. And when you do see it, it seems close to the sun. It must be pretty scorchy there. Now, with the scale model, though, we can see Mercury that I'm holding my hand the size of this black pinhead, and there's the sun out there. So there's an immense distance here. Mind you, Mercury's smaller than the Earth, and it's not much larger than our moon. When we look at Mercury, and now we look back at the sun, that's the actual size of the sun from the surface of Mercury, because this is a scale model. Well, enough talk. Back to the walk. Who knows what planet's next? That's right, it's Venus. 7 strides. 1, 2, 3, 4, 5, 6. Wow, quite a ride. Venus, where are you? Carefully I hold you. The planet Venus. I'm 67 million miles away. That's farther than Bangor, Fort Kent, Ashland, Presque Isle, Portland. This is 67 million miles away to scale. Now, if I look back at the sun, good golly, it looks smaller. And here is this broiling, nasty, never spend your summer vacation place, Venus. No moons, no liquid water. It's not a fun place. We know a little more about it than we certainly did years back. And who knows, in those clouds, maybe there's something living. I don't know. Goodbye, Venus. Carefully, I return Venus to its place into the planet cup. You know what's next? 9 strides. Take a deep breath. How long's every stride? 3 to 4 million miles. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. The spacecraft stops. What planet's next? Yep, you guessed it. The Earth, our planet. Home sweet home. And there's the sun. Smaller still. Now the fascinating thing about this moment, how on earth can the sun heat us up? We're really far away from the sun. This represents 93 million miles approximately. It's quite a distance, isn't it? Now the fun part about this, if you look back to the sun on your model, or ours for today, the interesting thing is that the size of the sun to the model is truly the size of the sun in the sky. To prove that, I'm going to take my welder's glass, put it to my eyes, and look up at the sun, look back at the ladder, and lo and behold, the sun on the ladder and the sun high up there. It's the same size. That way you know your model is to scale. Cool? No. Hot. We're not done yet. Maybe it's windy. Maybe you wonder if you've lost a pinhead. Things happen in life and in the solar system. I'm going to hammer with 10 strokes a stake here, so I know the Earth's position. You don't want to be lost in space. Now you've got a reference point. Who knows what planet's next? I'll give you a hint. Red planet. Yep, Mars. 12 strides. Here we go on the spacecraft. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, how do you do? Mars, we are here. I reach into my planet cup. I look for Mars. Where are you? Hiding. This makes an astronomy educator nervous when the planets aren't behaving. Matt Damon, eat your heart out. Mars, the red planet, subject of a ton of tales, target of many spacecraft from the Soviet Union, United States, Russia to this day, and others will follow. Will you see astronauts on Mars in your lifetime? I don't know. The prospect looks very feasible. Is there life on Mars? I don't know. But we're going to make every effort to discover what's going on the red planet. One more time, Mars. How many moons? Nope, not one. That's right, 2. And maybe from some of your books, you remember they're kind of shaped like potatoes, so butter them up. I'll put Mars back in the planet cup. I think everyone should take a deep breath. I hope I've constructively terrorized you a little bit. We're going into deep space now. This zone that I've covered between my humble person and the sun model represent the terrestrial or inner planets. But we're not done yet. We're going deep. Stand by. Energize. To Jupiter we go. 95 strides. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll try French. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Spanish. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, I'm tired, 38, 39, 40, 41, 42, 43, 44, 45, 46, beautiful day, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. What's next? Yep, 70, 71, 72, 73, 74, 75, 76. Let's keep going. March, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. 1, 2, 3, 4. Hurrah! Huzzah! Jessica! Tonga! Where am I? Whoa! Let's check it out. I'm looking for Jupiter. Feel mighty fine. I stake a claim. Jupiter, where are you? Giant Jupiter. Doesn't look so giant. Come a long way. And we look back at our ladder and our scale sun, old blue ball. Wow, we are in deep space. So one of the important ideas here, not only is the gigantic scale distance here, but boy, the sun looks awful small. And yet Jupiter in the sky from the Earth is mighty bright. It doesn't look like a ball, but it looks like a mighty bright star. So you might ask, and it would be scientific of you to ask, yeah, that's right, you got it. It must be huge. And it is. It is gigantic. It is bigger, bigger, bigger. And I wish I had 1,000 pinheads, because 1,000 pinheads would fit inside Jupiter. I'm feeling smarter already. And it's a little scary, actually. I'm really far away. The sun obviously is doing its job. And I'll ask you one further question, especially if you're 10 years old. If I gave you Jupiter and I asked you to walk around in an orbit about our school and our Jupiter to scale in time, how old would you be when you got back here after going around in orbit one time? Keep thinking. Don't give up. How long does it take Jupiter to go around? You got it. 12 years. If you're 10 years old now, Oh, you'll be shaving when you come back. You'll be 22 years old. Space is big. Incredible, really. But we're not done yet. Back into the planet cup, giant Jupiter. You probably also know that Jupiter has a family of moons. When I was your age, we only knew about 10 moons or 12 satellites around it. Today, take a deep breath, 79. No, I'm not that old, but that's a big number. Jupiter, go back in there. Who knows what planet's next? I'll give you a hint. Lord of the Rings. Saturn. Ready? Take out our signpost. 112 steps. Forward, march. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How am I doing? 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Posture, 40, 41, 42, 43, 44, 45, 46, 47, 48, 40. Stop playing Fortnite there. 51, 52. Pay attention. 53, 54, 55, 56, 57, 58, 59, 60, 61, 60. No, you can't walk the dog. 61, 64, 60, 66, 67, 8, 60. Now the cat. 79, 80, 81, 82, 3, 80. You can't clean your bedroom. 85, 6, 87, 88, 9, 90, 91, 92, 3, 94, 95, 6, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 110, 111, 100. I did it! Saturn! I know it's springtime now, the ground's not frozen. This is deep space. I can barely see the ladder. And I can see the sun, but this is chilly out here. Saturn, there you are. There's nothing more beautiful, I found, as an astronomer, hobbyist, teacher, is seeing Saturn in the telescope. It's so far away, you need one to be able to see the mighty ring of Saturn here. That ring is so long it could fit between the Earth and the Moon. And it's thin, mighty thin. I've read reports it might only be as thick as this stick. You know, nature's funny. I'm trying to be funny too. We're at Saturn, and we can see the sun has dwindled down to the teeny weeny sun silly beanie out there. The immensity of space. You 10-year-olds, here's your chance again. If I give you Saturn and ask you to walk the walk, how old are you going to be when you get back here to scale in time? Take a deep breath, because you're probably going to, well, not believe me, 40 years old. You ever thought about what you're going to look like when you're 40? I have to look backward to think about what I used to look like when I was 40. What will the world be like in the year 2060, 40 years from now? What will people be driving, eating? How will people dress, haircuts? What will be the state of the state? Where will you be working or living? We shouldn't be frightened of the future. We should look forward to it. And what are we doing today to make our future a brighter, more successful one? Saturn, with its family of moons. I've read that in spite of the 52 known satellites mentioned in the Saturnian system, there could literally, in the final analysis, be a couple hundred of them. Sounds like a traffic jam to me. Aren't you glad we don't have 200 moons in our sky at night? Maybe you don't care. Therefore, we're going to have to go on deeper. I'm going to return Return Saturn to its proper place in the Greek planet cup. Thank you. Who knows what planet's next? I know it's your favorite. The old turquoise green gem Uranus. 229 spaces and places and paces. Here we go. 1, 2, 3, 4, 5, 6, 7. 19, I'm walking the walk. I'm not talking the talk. I need to focus. 45. Beautiful day here in outer space. 60. 70. I don't know if I can do it, but I must endure. 80. For the sake of the solar system going on. 90. 100. 110. I'm still walking. Are you still listening? 120. Come on, this is a good lesson. Bet you can't wait to walk this out. 135. 55. I'm still going. Here's a little thin. There's no air here. 165. We're pretending though. Come on. Aren't you having fun there watching me struggle? 175. I'm motoring, but this is deep space. 195. 200. Mission Control is giving me a course correction. 205. 210. I'm still smiling. There. I just had a course adjustment. 219 steps. We're in trouble. The sun is out of visibility. Now, in reality, our pacing represents close to 2 billion miles, over 3 billion kilometers. This is incredible. I mean, it's kind of scary when you think about it. Space is immense, and we're just talking about our neighborhood in the universe, the solar system, to scale, mind you. My apprehension is leading to some comprehension and tension. Where's that Uranian I found it! Found it! Here it is. You never thought I'd find it. Uranian planet. 10-year-olds, check it out. How long would it take for you to walk with your Uranian planet in one orbit and come back? You're not going to like my answer. It broke! Well, it's just a peanut. Give me a break. You'd be 96 years old. Actually, 94. I made a mistake. Will you forgive me? 94 years. What do you think you're going to look like when you're 94? What are you going to eat when you're 94? 94? That's the 22nd century. I don't know. It's a little too deep for me. We've only got one more to go. You want it? You don't want to go any? You're tired? You're cold? I know I'm not boring you. But you want to check out Neptune, don't you? All right, we'll start. Don't fall asleep. You're sleeping. I hope there's a mom or a dad or a family member to jog the kids up. We've got one more planet. I'm going all the way. Neptune! Ho! 1, 2, 6, 7. I never dreamed I
I was going to be doing this when I was a kid. I just wanted to go swimming, drink lemonade, ride my bike, watch TV, watch more TV, watch more TV, maybe go to a movie if I had some money. Those are the days when, in early childhood, on a Saturday afternoon, 100, I could go to the movies for 35 cents. That's right, you heard it. 35 cents. And boy, that's when movies were movies. It was a lot of fun. I've often wondered, as I've continued in this astronomy education career, why I'm doing this. So many things you can do as an adult in life. But when you're looking for passion and you're looking for communication and you're looking for purpose, I think astronomy offers just the most exciting venues and the ability to satisfy your curiosity about the unknown, the mysterious, the great places of space. And how do people fit into all this? And why do you need to know this anyways if all you want to do is go to school and find a job and maybe raise a family? And well, my feeling is, in the final analysis, we really want to be able to go and learn where we are. It's that human sense of adventure and curiosity, don't you? 150. And, you know, I'm curious about it too. Been interesting, and you never know who you're going to meet in outer space. Could be other astronauts. If you're from Maine and listening to this, you know that one of our own traveled around the Earth recently, Jessica Meir of Caribou, Maine. And Chris Cassidy from York, Maine, is currently on board the space station, the International Space Station. You know, there's so many things to see. And our journey's just about over, 200. We've been striving and trying to do our best to understand the solar system to scale. And I hope you begin to understand reality is a little scary when it comes to spacey stuff. It's not just watching a movie or a quick computer game. The true places in space are awesome. We give ourselves a lot of credit for being able to explore by spacecraft and telescope and all other instruments some of the wonders of space. I'm so excited to have a chance to see. Wait a minute, it looks like there's some other astronauts up ahead. Welcome, fellow astronauts.
Hello.
We're here recording a video for the community on the solar system scale, and we're happy to see it. We're not alone out at Neptune.
No, we're just out for a walk.
Did you study the planet? Do you think that it's going to be part of our scientific curriculum in the future?
It could be.
Excellent. Well, it's nice knowing you.
We'll let you continue.
Yes, navigate back safely home.
You too.
Make it a great day. Neptune. This is an awesome experience. Depths of space. And could it possibly be true that our exploration to Neptune brought us into an incredible flyby situation back in 1989? That seems like ancient history, doesn't it? Sure does. It's 31 years ago that Voyager 2 spacecraft flew by this planet Neptune. So let's go fly by ourselves. Put in our Neptune post. Now when you make your own model, and we've walked about 2/3 of a mile, you might not have this much room. Maybe you just want to do the inner planets. Or maybe you have to go at a right angle to get the rest of the planets in. Or maybe you just want to double back. That's okay. The key is that you're on the move and you're turning your book knowledge about the solar system into practical hands-on scaling and activity mode. The old Chinese proverb said, I hear and I forget. I see and I remember. But I do and I understand. So we're looking for that apprehension, that understanding, that comprehension. And you've been very good taking the little walk with me here. We've been out longer than I expected, but space is big. Neptune! All right, 10-year-olds, I've got to do it. If you took a Neptunian orbit with this planet, this giant, this gassy giant, ice giant, how old would you be when you got back? I don't think you're coming back. You'd be 175 years old. And that is a long time. Neptune, I salute you. It's time to go back home. I want to thank everyone to joining me, the friendly astronomer. We're going to walk the walk back. I hope that our walk today has given you questions and information and experience in terms of the solar system and a better understanding of how we really try to better understand our place in space. Space is big, but we shouldn't be afraid of it. It should be something that is worthy of our exploration and human curiosity and knowledge. Our opportunity to grow continues all the time, and I think that astronomy as a science, as a life skill, is going to provide a great experience for all of you. Come on, let's walk back a little bit and we can talk about the planets while we close our program for today. This has been the third installment of The Friendly Astronomer. Our future installments will cover other areas of interest in space, but the solar system is an important one for kids. We want you to have a better understanding of just where you are and how we can actually get a grip on something that's so far away and so big. Now you might want to be asking me, and I hope you're thinking about the solar system personally and participatorially. I just made up that word. How can I see these planets? You know, these again are models, but where are they really? Well, it's 2020, isn't it? The last time I looked at my calendar. And it's not April, and it's not June, it's May, and it's the latter end of May. So what can I do if I, for example, want to actually see the planets themselves, and I don't even have a telescope or even binoculars? Can I see them? I mean, it looks easy the way you do it here, and the answer is yes. So I want to give you a brief tip in 2020 in May, how to find, at this particular time, believe it or not, 5 planets of the solar system, not the Earth. And what are they? Mercury, Venus, Mars, Jupiter, and Saturn. All are visible to you or someone with you in the family from a safe spot around your home. And I'm going to show you right now how to do so. I'm facing currently, in looking at you, due south. Nothing personal, but I'm turning my back to you and I'm facing the north. Now I take a right angle and I'm facing east. And if I go in the opposite direction, I'm facing west. I'll use my friendly pointer to help. West, northwest, north, northeast, east, southeast, south, southwest. Interesting, isn't it? You can do that. A lot of our smartphones have compasses built right in them that give you the cardinal direction and even the degree measurement to determine by number exactly your position in your sights. Planet number 1 and planet number 2 for visual inspection in May of 2020 are Mercury and Venus. It's approximately 8 to 8:30 at night, and these are clear nights at the end of May. I'm facing where? Right, the northwest. If I go about 2 hand spans up into the sky in the northwest at 8 or 8:30, after the sun goes down, mind you, which is very late in May, maybe 8:30, even toward 9, you're going to see a very bright star, very low. You've probably already seen it. And maybe many of you know you're looking at the planet Venus, our sister planet. That was the yellow pinhead. With your eye very closely in scrutiny, you may see a much fainter star point that are about 3 fingers beneath Venus toward the horizon. Binoculars will show it easily, and it's the planet Mercury. Venus and Mercury, side by side, a very rare close-up between those two. Did you like that? What do you mean? You're in bed by then? Well, okay. That must mean you're waking up early. How early? Well, in late May, maybe 4 in the morning. Yeah, you got that right. That's what I said, 4 in the morning. Because sunrise comes very early in late May. It actually comes up a little before 5 in the morning. If you're up for many reasons at 4 in the morning in late May, you face where? Yep, south, southeast, south, southeast. In between the south and the southeast, you're going to see 2 stars, and they're quite bright. I bet some of you parents, if you're listening to me, have seen them, or other family members in the adult realm. One's quite bright, and the one further east is not so bright. maybe it's farther away or smaller, and both are true. The brighter star point at 4 in the morning in late May is the planet Jupiter. And the star not quite as bright next to it, and they're close. They're only 3 fingers apart. The planet Saturn. What do you think of that? The Lord of the Rings, the 2 Jovian giants side by side. Wonder what they're talking about. Further to the east, and I did it myself this morning, about a handspan and a fist, is a 3rd star. It's quite easy to see, but it must be kind of lonely. It's far away from the other pair. And it looks kind of red, because it's the red planet. It's Mars. Jupiter, Saturn, and Mars. Isn't that interesting? Come on, let's go home. We're going to take our walk back to the Earth. We're striding here between Neptune and the Uranian planet. It's been an exciting walk. I want to thank all of you for joining me and giving me this time to talk about the solar system. There's much to learn. I want everyone and encourage everyone, especially by the family force, to go out and actually create your own scale model. If your space is limited in terms of your home yard or even near the neighborhood, just do the inner planets. Or you may even just want to start with the Earth and the Moon. We can even review that if you want to and care to do so. The important thing is that you're out walking the walk as well as talking the talk. And what's important then is that you can share the walking and the talking first with your family, then with your friends. When school starts, you have the opportunity to be top of the class and bringing the solar system to the school and helping everyone get a better clue about that particular place in space. Furthermore, if this study of the solar system interests you, a telescope and certainly a pair of binoculars seems quite in order. You can have the opportunity then to gaze more and more often into the sky and become more familiar with the motion of the planets. Because don't forget, from the Greek, like the yogurt cup, planet is from the Greek word planetes, wanderer, the wandering stars. And the wandering is noticeable. The planets closer to the Earth seem to wander with more range of motion than those farther away. So Mercury, Venus, and Mars, the terrestrial planets, seem in the sky to move with dispatch and strange motions that become predictable finally after so much study. The larger planets, so much farther away, the Jovian worlds, Jupiter, Saturn, Uranus, Neptune, much slower in orbit, and their motions are much slower too than the inner worlds, the terrestrial planets. All these are important facts to be learning as you're growing and beginning to understand the solar system better. Planets travel through constellations in the sky too. Currently, Mercury and Venus are through the stars of the Bull. You remember that? Taurus, the Bull. In the morning sky, Jupiter is residing, taking residence in the Archer of Sagittarius, and Mars through the Sea Goat, Capricornus. All these constellations are part of the zodiac, which are 12 or actually 13 constellations, which the Sun and the Moon and all the planets seem to drift through. These constellations probably should be your starting point for learning more about the night sky. And let's not forget, one of the benefits of Aroostook County, Maine, northern Maine, and much of the state of Maine, and many parts of New England, even areas east of the Mississippi, are filled with dark skies still. We need to be aware of that and to be conscious of enjoying and benefiting from the darkness in an appropriate and safe and secure way so that you become more familiar with our place in space. Because no matter what the human presence does with its technology, we still are inhabitants on the pale blue dot, the small Earth, the good ship Earth. And it's important to be able to be more aware of the reality of our astronomical position. It gives us a sense of humility. And I think that's really important in life, to be appropriately humbled in a way so that we can continue to better understand our unique role in the solar system. The exploration of the solar system for you children will be continuing in a mighty way in the 21st century. We've just learned recently that a new NASA mission will go back to Saturn in the year 2026, only 6 years from now. And it's going to be exploring Saturn's moon Titan. And somebody should know probably much about that Titan, that it's the only satellite in the solar system we know that has an atmosphere. And not only that, within the atmosphere and on the surface itself are evidence of liquids that are not water, ethane, methane, and other unusual chemicals, at least from an Earth point of view, that dominate the scene. Is there life on Titan? Well, we got to go and find out. That's one of the themes of astronomy too, life beyond Earth. The search for life beyond Earth continues. Well, you've done very well so far. We've come back to Saturn in terms of our scale model. We can even see from a distance, we've returned to the sun. It's remote, but I can feel the heat a little bit. I'm ready for a tan, I think, at this point. We're going to continue our journey. It's so good to be back home. The opportunity to show the scale model of the solar system has been a personal treat for me. I've been performing the solar system model for years at this point, locally. If you have further interest in learning about the model and you want to contact any of us at the Francis Malcolm Science Center, we'd be happy to talk to you about it, or trying to set up the materials that you need to make an effective model. And I have to warn you, once you do it, you're probably going to want to do it again, or the kids are going to certainly want to do it again. And it's very exciting, and I think it's a family building activity as well too. Gives everyone a chance for a good walk. It's almost like playing a round of golf or frisbee golf. You can go out and get out in the sunshine, and isn't it wonderful that springs come back and everything is just, you know the word, green, life. Wonderful to see back again here as we continue moving on our own scale model. We're at Jupiter right now, and pretty soon we're going to be heading back to Mars. Hopefully our stake is still in place for the Earth. Our navigation's been pretty successful so far, but I hope it'll get us back home. We're going to stop here at the Jupiter point and look back again at our sun and have an opportunity to see it does seem to be growing in size. Can't you feel that heat? Sure you can. Aren't you feeling warmer already? Oh, what a magnificent experience. The solar system peppercorn model, originally designed by Guy Otwell, and now conducted by myself and probably scores of other people as well. One of the great activities in astronomy education on the popular level, but even from the professional level, because so much of us as professionals seem to learn more and more information, but it's very hard to apprehend and really develop the keen sense of awe that comes with scale modeling, which we're doing here. And maybe this will give you your own ideas of how you'd like to proceed and develop your own astronomy lessons and sharing the universe. That's one of the greatest lessons that I've learned in my decades of astronomy education. Sharing the universe. How do you work together with everybody to better understand our place in space through exercise or through instrumentation or through some of the simple talking? There are many, many ways we can learn more about the solar system, and I really think we should, especially, as I was mentioning earlier, in the 21st century, as spacecraft begins to probe more deeply than ever. And that's where you come in, you kids. Perhaps a career in engineering, or an opportunity in space science, or with NASA, or with maybe SpaceX might interest some of you too. Keep exploring. It's so important to become more aware of your place in space in the 21st century, and science in general. Astronomy is one of the most powerful elemental forces in science, and has been for centuries, to be able to draw us into that greater sense and scheme of just who we are, and be unfolding in knowledge and information and apprehension and awe of where we are in space. We really strongly believe as astronomers that developing that sense of awe with our children and our grandchildren gives us an opportunity and hope for the future, that as we understand the humility of being part of this immense, unfathomable at times universe, that we have a sense of humility and goodwill toward each other. And hopefully with the aspect and the future insight that we can build a kinder community because we need one another. This is all we've got right now. There may be life on Mars, we don't know. There may be life in the oceans of Europa, we cannot say. But one thing is certain, that we'll never surrender our search for scientific insight and truth. Astronomical truth and insight has been a great benefit to the human purpose. And I'd like to thank everyone for joining me and being part of that purpose too. Ah yes, I can see our Earth stick is still in place. Happy to see that. We're right now about the level of Mars, the red planet, and we're returning to the warmth and friendly confines of the solar system inner realm, Earth and its neighbors. What a great experience it is to be able to share the solar system with you today. We've covered 3 billion miles out, 3 billion miles in. The entire solar system, when you think about it, is close in many ways to 1,000th of a light year. And as you know, probably from some of your studies, if you're more advanced, that most of the stars in the intergalactic space are in the light years, if not millions of light years. To scale model those factors is a very different lesson than the one we have today. I'm going to pick up the Earth stick. We're going to head back to the sun. Again, as your friendly astronomer, Larry Burse from the Francis Malcolm Science Center and the Maine School of Science and Mathematics, I'm very happy to be able to share a nice walk with you. I had a good workout. I hope you aren't too tired from all of that. We had a very nice experience, and we're going to continue our journey to other realms in astronomy in future installments of The Friendly Astronomer. Thank you, son. I'm going to return my equipment. And I'll end with a final tune to sum it all up. Many years ago, an American president said this: "In the final analysis, our most basic common link is that we all inhabit this small planet. We all breathe the same air. We all cherish our children's future. And we're all mortal, so we're going to make every day count. I shall not be afraid to shout my planet's cry. The solar system now reborn, my personal insight. We shall not be afraid to shout our planet's cry. The solar system now reborn, our collective insight. The solar system now reborn, our collective insight. This is Larry Burrs, the Friendly Astronomer, saying live long and prosper and stay the course. Keep looking up. Make it a great day, everybody. Thank you.